Hello, in this video we're going to take a look at solving linear equations that involve fractions. This goes along with pretty much any section in Chapter 5 of the book. There's no section dedicated to solving equations with fractions, but students often tell me they have a hard time with these, so I wanted to make sure to dedicate a video directly for these types of questions. So the directions will typically say the same thing as usual when solving equations, and I'm going to assume you've already familiarized yourself with the general process for solving either one or two-step equations. That's sections 5.3 and 5.4 in the textbook. If you haven't, please make sure to check out those videos and read through the textbook sections before watching this video. Alright, so I'm going to solve the equation for x, and the directions say to write your answer as a fraction in lowest terms or a decimal rounded to the hundredths place. There are at least three different possible methods for dealing with the fractions in this equation. I'm not going to use the textbook's method first, but I will go over that method. The first method I'm going to use is the direct approach. But before I do any of these methods, I do want to make sure that I go over rule number one, the cardinal rule for dealing with fraction equations. The very first step, the very most important thing that you can do is not panic. These questions look scary, but they're not nearly as bad as you think they are. As long as you take things step by step, write out all your work, and compartmentalize, don't try to do everything at once, you should be fine. This is a long question for sure, and it involves a lot of steps, but as long as you go one step at a time, each individual step isn't too bad. So the first method, like I said, is the direct approach. I'm going to go ahead and deal with the fractions head on. I'm going to take the fraction arithmetic to the side and just use the rules that we learned back in week 2 for adding, subtracting, multiplying, and dividing fractions. Before I do any of that, I always want to start with the algebra. Deal with algebra first. So pretend like these numbers aren't even fractions and just solve this as a normal two-step equation from section 5.4. If you go back and review that process, the very first thing you want to do is take a look at the numbers on the side of the equation with your variable. So I'm going to split this guy in half. And on the same side as x, I have a 4/5 and a 1/6. And I always cancel out the addition or subtraction first. So I'm going to cancel out this plus 1/6 with a minus 1/6. I'm going to do it directly underneath on both sides of the equation. I don't have to know a thing about fractions in order to do this. I just need to know my algebra. So do your algebra first. Write out what you need to. And now we have to evaluate top to bottom. Well, I'll go ahead and do the harder one for you and let you do the easy one. 1/6 minus 1/6 is 0. Okay, go ahead and do the easy part. 2/3 minus 1/6. Alright, that was a bit of a joke. But still, 2/3 minus 1/6 is something that you should know how to do, even though it's harder than 1/6 minus 1/6. If you don't, make sure that you review your fraction arithmetic because it is super important. But as it says here, take the fraction arithmetic off to the side so that it doesn't clutter up the rest of your work. We can do it right here. 2/3 minus 1/6. See if you can pause the video and do this one on your own, and then come back. Alright, did you try it out? 2/3 minus 1/6, do you remember how to subtract fractions? We have to find a common denominator, right? For 3 and 6, a good common denominator to use would be 6, because 3 goes into 6 and so does 6. And just as before, I have to divide the denominators, then multiply by the numerator to get my new numerator. 3 goes into 6 2 times, so I'm going to multiply by 2 up here and get 4. 6 goes into 6 one time, so negative 1 times 1 is going to give me another negative 1. And then 4 minus 1, when I do that subtraction, will give me 3/6. Now I ought to reduce this to lowest terms just to make my life easier, and since the top and the bottom are both divisible by 3, I'll go ahead and divide by 3 on the top and the bottom. It's a good idea to generally reduce your fractions to lowest terms, though you don't need to in this step. You could just leave it as 3/6 and that would be fine. You would just have to reduce at the end. But I'll get 1/2 here. Now where does that go? You have to go back and remember what you were doing. So in the algebra you were doing 2/3 minus 1/6, and we'll write our answer directly underneath is 1/2. So I'm going to go ahead and write that down. Sometimes what I'll do is I'll actually put like a little bracket here just to remind myself that's where my answer ought to go. And now I should end each step with a full equation, so I'll have to put an equal sign here and then bring down whatever's on the other side. Well, here's the only remaining piece here is the 4/5 x. So I have 4/5 x, or 4/5 times x, equals 1/2. Step 1, done. Phew, that was pretty long, but we successfully did it. Again, just treat this as one step at a time. Start off by doing your algebra, figure out what you need to do to both sides. When you hit a fraction arithmetic problem, take it off to the side and then do that fraction subtraction or whatever it happens to be, going through those steps as though it were its own little separate problem. Make sure to take it slow and double check your work. There are so many steps altogether to this question that it's very easy to make one little tiny mistake that throws the whole thing off. Okay, next step. If I have a number that's touching the x that's multiplied with x, and I'm going to want to cancel that out last. So I'm going to cancel out this 4/5 that's touching the x by dividing both sides by 4/5. Instead of using a fraction bar here, I'm going to actually use a little division symbol, divided by 4/5. And I'll write the same thing on the other side, divided by 4/5. When I take this over to the side, I want to write it out horizontally, meaning left to right, and it's always top number first, then bottom number. So my fraction work I take to the side, it's going to be 1/2 divided by 4/5. And I'll go ahead and put the brackets, like I said, underneath so I know that where my answer should go is right there. So when dividing fractions, remember you always flip that second fraction. If you want to get technical, you say that you take the multiplicative inverse, or the reciprocal, and you change the division to a multiplication. So that division turns into multiplication, and the 4/5 is going to change to 5/4, or 5/4. And now I can multiply straight across. There's no real cross-canceling I can do here or reducing. So I'm going to multiply 1 by 5 to get 5, and 2 by 4 to get 8. And it just so happens that that is in lowest terms, but it's always good to check. So I'm going to put my 5/8 where that little bracket was, since that's where I left a spot for it. And I have to make sure I end with a full equation, so I'll bring down my equal sign. I'll check out what's happening on the other side. Oh, and that was the hard part, right? We just did the easy part. Okay, little joke again. 4/5 divided by 4/5 is the easy part for real. And then I bring down my x. And there's my final answer. X equals 5/8. So that was the direct method. If you don't like that method, that's fine. You've got two other options here, and we're going to go over them. Next option. What if we convert those fractions to decimals? That's something that you've learned how to do. In fact, that was an assignment for week 3. To convert a fraction to decimal, you just do the top divided by the bottom. But be careful here. Rounding error can be compounded by multiple arithmetic operations. So do not round until the very end of this question. That's what makes the rounding option unappealing a lot of the times. And you'll see why when I do this particular question. So I'll draw my line down the middle as usual, but I'm going to convert each of these fractions to a decimal. So 4/5. 4 divided by 5 isn't so bad when you do 4 divided by 5. If you punch that into your calculator, it's just going to tell you 0.8. So this is going to become 0.8. And then I bring down my x. So that just gave me 0.8. Unfortunately, 1 divided by 6 is rather ugly. If you do 1 divided by 6 in your calculator, it's going to tell you this horrible repeating decimal, 0.1666666666, and those 6's just keep on going forever and ever, and they don't stop. You'll probably see a 7 at the end, but that doesn't mean that there's a 7 anywhere in there. It just means that your calculator rounded for you. Go ahead and type in whatever your calculator, or write down rather, whatever your calculator says, but don't round it. So in this case, I'm getting 0.1666666667. That's what my calculator says. I'm just writing that down exactly. Equals, and then 2/3 again is going to be a horrible decimal. 2 divided by 3, go ahead and punch it in your machine to see what it says, but it's probably telling you a really ugly decimal as well. Are you getting something like 0.6666, a bunch of 6's repeating? That's what I'm getting. So getting 0.6666666667, I believe is what I have. Well, that's just terrible. You can see why the converting to decimal method isn't all that great. Well, let's go ahead and do our next step, which is we're going to cancel out the numbers that are on the same side as the x. So just as before, the number that's touching the x, that's being multiplied with x, is the last to go. And I'm going to cancel out this plus 1.6666666 and so on first. So I'll do minus 0.166, and I'm just going to put a dot, dot, dot here for now. And I'm going to do the same thing on the other side. Minus 0.1666 and so on. And put a dot, dot, dot. That's okay for showing your work, but remember, when you put this into your calculator to evaluate, please make sure that you do not round. Write the whole thing down. Because what's going to happen in this particular case is that the repeating decimals will actually cancel, and you should get 0.5 on the nose. I'll bring down my equal sign, and I'm also going to bring down my 0.8x. Last but not least, we did our addition subtraction step, so I'm going to divide by the coefficient of x. I'm going to take a look at the number that's still with x, and that's the 0.8. Since it's touching the x, I have to cancel it out by dividing 0.8 on both sides. Now, if you take a look at this, and if you take a look at the previous example, which was exactly the same, you notice 5 over 8 was our answer to the previous one. Well, I've got 0.5 over 0.8. You could probably guess that that's actually exactly the same thing. And you can evaluate this by dividing. When you divide 0.5 by 0.8, you'll get 0.625. And that's almost our final answer, but we just have to pay attention to the fine print, which says round this to the hundredths place. And it just so happens that my hundredths place is the 2. So now you're allowed to round. You were not allowed to round before, but now you can. And since my hundredths place is the 2, this is my final answer, I can round that. And that 2 is going to bump up to a 3 since it's followed by a 5. And 0.63 would be my final answer. Would have been the same decimal equivalent first for the first one, which was the same exact question. All right, we're going to solve this question, the same exact one, again, using a third method. And this is the textbook's method, which is to multiply through by the least common multiple of all your denominators. I don't really like this method all that much because I notice people often make mistakes with it, especially if parentheses are involved in a question. But I will go over it in case it happens to be a method that you like. So the first thing that we need to do if you're using this method is to take a look at all three of your denominators, in this case 5, 6, and 3, and find the least common multiple of those three numbers. This is kind of like finding a common denominator from the Chapter 2 addition and subtraction of fraction questions. You're going to look for a larger number that 5, 6, and 3 all go into, a multiple of all three of them. Well, 6 is already a multiple of 3, so I can pretty much ignore the 3 because anything that's a multiple of 6 is automatically a multiple of 3, and I just need to find a multiple of 5 and 6. You can look on the multiplication table in DocSharing in the 5's column and in the 6's column, and you'll see that a number they have in common is 30. There's other ways to find a least common multiple, but that's probably one of the better ones. So we'll go ahead and use 30. And that means I'm going to multiply each one of these things times 30. So I'll write 30 times here, and 30 times over here. If you were wondering why my fractions were spaced apart, that's why. And then 30 times over here. I wanted to leave some room to put that in. So multiply each thing by 30, and you can make it a 30 over 1 so that you can multiply the fractions if you want. And what's going to happen is that cross-canceling will make it so that each of these turns out to be a whole number. For instance, for this first multiplication, 30 and 5 can cross-cancel. 5 goes into both of those, and when I divide by 5, 30 divided by 5 is 6, and 5 divided by 5 is just 1. So this is no longer a fraction, it's just going to be 6 times 4. 6 times 4 is 24, so that gives me a 24x here. Something similar is going to happen with the second pair of numbers, the second pair of fractions here. 30 and 6 can both cross-cancel. 6 goes into both of those, so I'm going to divide by 6. 30 divided by 6 gives me 5. 6 divided by 6 gives me 1. I'll have 5 times 1 on top, which is just 5. And 1 times 1 on the bottom is 1, and I don't have to write it because it's a denominator of 1. So I have 5 here. And then last but not least, the 30 and the 3 will cancel. So when I cross cancel here, I'm dividing by 3. So when I divide by 3, 30 divided by 3 gives me 10, and 3 divided by 3 gives me 1. 10 times 2 over here is 20, and then again your denominators are going to cancel out. 1 times 1 is still 1, so you don't have to worry about them. And now this is an equation without any fractions. We can go ahead and solve this the usual way. So just as before, take a look at the numbers that are on the same side as your x, draw your line. On the same side as x is that 5 and that 24, but I always cancel my addition or subtraction first. So I'm going to do a minus 5, and then I do my minus 5 on the other side as well. 20 minus 5 is going to give me 15. And then the 5's cancel, and I bring down my 24x. Last but not least, I take a look at the number that's the coefficient of x, the number that's touching x, and that's the 24. I've got to cancel that out next. Since it's being multiplied with the x, I divide both sides by 24. So I'll put my fraction bar over 24 and over 24 here. 24 over 24 cancels, so that's going to be out of the picture, and I'll just be left with x on the left side. And on the right, I've got a fraction that I can work with. X equals 15 over 24. Now you can divide to turn that into a decimal, but since it's already a fraction, you might want to reduce it to lowest terms instead. The process for doing that, you just look for a number that you can divide the top and bottom by. In this case, 3. Divide by 3, and divide by 3. So when I work this out, 15 divided by 3 is going to give me 5. And then 24 divided by 3 is going to give me 8. Well, look at that, the same answer, yet again. So all three of these methods gave me the same answer. They each have their pluses and minuses, so experiment with them, figure out which one is the right one for you, and stick with it. I'll accept any of these methods as an explanation for the homework post if you choose to do a fraction problem for your homework, and kudos to you if you do. For the Hawks assignments that involve fractions, any of those three methods will get you the same answer, so you can use whichever one you'd like. In summary, there's 3 different methods for solving linear equations that involve fractions. You can take the fractions to the side to do your fraction arithmetic and then get your final answer that way. You can convert your fractions to decimals and then work with the decimals. Now I know the textbook tells you some nonsense about multiplying by 10 if you have decimals, but please completely ignore that. Or lastly, you can use the textbook method of finding the least common multiple and multiplying each fraction by that to cancel out the denominators. All 3 of these methods will give you the same answer, so you're welcome to use any one of them.